Hey guys, hope you are doing better than me. Apologize for the super grogginess. I'm a little sick today, but I just wanted to go over. I want to move on to chapter 2, and that was my intention today, but life happens. So, anyways, I have a short little video to introduce what the difference is between velocity and speed. And how to find average velocity. So it shouldn't really take too long because most of you kind of already know what speed is, or velocity, right? Because like you drive and you know your speed as you're going because you've got the speedometer. But more like as we go on, we're going to talk more about instantaneous velocity, which is more about like what is your speed or what's your velocity at a given instant. And so things like speeding tickets, running races, and like having a clocked speed, or like one of those baseball pits, where you throw and it tells you what the speed is of the ball. Like that's instantaneous speed. And so sometimes it's like kind of hard to measure. Like it's easier to measure like average speed, right? Average velocity, because you can like take the distance that it traveled divided by the time it took to get there. But if the time that you're looking at like is 0, then it's instantaneous, and that's kind of confusing, and it's hard to calculate just by like taking distance divided by time. So anyway, so we're gonna like focus more on instantaneous speed later, but this section we're just gonna talk about average speed. So there is a distinction, a big difference between velocity and speed. You probably have heard both of them used interchangeably, but velocity and speed both kind of measure like the rate at which you're moving or the rate at which something is moving. But speed is always like the distance that you traveled divided by the time it took you to travel there. So say for example, I walk around Dawson and it takes me 20 minutes, and I go this way, and then I go this way, and then I go this way, and then I go this way. And the total time took 20 minutes. And I traveled a total of like, I don't know, a mile, right? I could get my average speed by doing, I traveled 1 mile divided by 20 minutes, right? And I could get my average speed doing that. The velocity, on the other hand, is a change in position. So in this particular case, I started at my classroom and I also ended at my classroom. So my velocity in this case, because my position didn't change, is actually 0 because I have gone nowhere. So velocity has direction. Speed does not. Speed is about the distance that you traveled. Velocity is about the position change. Like, did I go from my room to Mr. Hannon's room, or did I go from my room to Mr. Hannon's room and back to my room? In which case, I have not moved at all over that amount of time. And then, you have to kind of like, for velocity, you have to kind of pick a direction, right? So typically, up is a positive velocity, down is negative, right is typically positive, and left is typically negative. So if I say I have a positive velocity, there's a ball and it's going up in the air and then back down, and in a particular moment its velocity is positive 2 meters per second. That would be in the positive y direction going up, and then negative would be coming back down. Um, speed, on the other hand, will always be positive because it's about the distance that you travel. And it is also known as the magnitude of velocity. So that term is probably new for you, but uh, yeah, that's a long story short, vocab words. So if you let S of t be the position of an object at any time, its average velocity over a certain interval from A to B. So like this is my time, and my time interval is from time A to time B. The average velocity is the change in position. So S of B minus S of A over B minus A, which is just whatever your position is at the end minus the position at your start divided by the difference in time, or the time it took you to get from point A to point B. This should also look familiar because it's kind of related to our slope formula for a line, right? Y equals, sorry, if you have a line, right, the slope of that line is the change in y over the change in x. And in this case, S of t is my y. So here's my change in y, and t is my x. So this is my change in time. We have just a short example. Find the average. Okay, so we're throwing a grapefruit in the air. I don't know why we're throwing a grapefruit. This is from the book. It's an example from the book. They're throwing a grapefruit. I don't typically throw grapefruits. Maybe pumpkins because it's close to Halloween and that's exciting. But anyways, whatever. You're throwing a grapefruit in the air. And you're curious about its velocity, which again, why? I don't know. Anyways, so these are some data points from that from the grapefruit. So your time, like after 0 seconds, your height of the grapefruit is 6 feet in the air. And then after 1 second, it's 90 feet in the air. And after 2 seconds, it's at 142 feet in the air, and so on and so forth, right? So you just have an XY table here. And the question is, what is the average speed of the grapefruit from on the interval from 5 to 6? And then also, what is the average velocity? So answer the question, what is the average speed and what is the average velocity? Go ahead and try that first. So pretty simple in this case. Your average velocity is your 30 minus 106 divided by 6 minus 5. You change in position over your change in time. And then your average speed in this case is just the absolute value of that, right? That's the magnitude of the velocity, because I'm going, the velocity is negative because it's going down, but the speed is positive because you can't go a negative distance. And speed measures the distance, change in distance over time instead of change in position. So this is kind of like just an interesting way to observe motion. So if you look here, the y-axis is the position. This could be the y position, so maybe whatever this particle is, it's going up and down, or maybe it's going side to side. We don't particularly know in this case. But basically what you have on the x-axis is the time, and then the particle's position over time. So after like 0.6 seconds, the particle's position is at like negative 0.75. And then it comes back to 0. So this is like, I don't know, a ball that like, you have a table and the ball like rolls off the table from 0. So say the table is at position 0, it rolls off the table and then bounces and then comes back up, would be this kind of motion. And so if you see, when I press start, you'll see the particle just like moving up here on the left, while the time changes here. So if I hit start, right, you'll see the particle going down and then coming back up. Whee! this is not exactly a ball, but like that's kind of the idea. Um, and at the same time, you also see that there's an x and y value for, as time goes on. So like here, if I have, let's stop, right? If I, right here, a time is, I don't know, about 0.7, then my particle's position is at negative 0.75 or whatever it is. And I could keep going and stop. And now it's past 0 again. And now it's like maybe 0.1 seconds later, and has moved up like 1.1 seconds and is now at the position positive 0.5. So this could be like a ball bouncing up and down, right, where like below the table is negative position and above the table is positive position. Or it could be a car, maybe like if your house is position 0, you like go west first and then you come back and you pass, right? This is like going west, and then you come back and you pass your house, right? Because here your position 0 again, and then you keep, and then you would accelerate past your house in the opposite direction, going east. So a lot of different like ways to observe motion. So it can definitely be kind of confusing, right? Because we have like a particle going one dimension, right? But we have a two-dimensional graph here. But because we want to like describe the motion with respect to time, because that will show us like the speed and the velocity. So something else to kind of pay attention to is acceleration. So when you're driving, right, if you're going at constant speed, like say you're on the throughway and you put on, what's it called, cruise control, there it is, you go the same speed the whole time, right? But that's not the case most of the time when you're driving. Usually you're like accelerating and decelerating, you're using the brakes and you're using the gas. And so like in this case, right, this particle will be from here to here is going to actually be decelerating, right? It's going in a positive direction, but it's going slower, right? And then after here, it's going to start speeding up again, meaning that it's accelerating in that portion of the graph. So if you watch the particle, it starts out slow and then gets faster and faster and faster and faster. Whee! So in that case, actually, your acceleration in both cases is down, like gravity, right? Gravity's kind of pulling whatever the particle is, the ball or the grapefruit or whatever. So even if I'm going up, right, if I'm moving up, I can still be decelerating or accelerating in a negative direction. And at some point, that will take me to a velocity of 0, and then I have to go down and I start going the other direction, right? It's just like throwing a ball up in the air, right? It's like the instant it leaves your hand, it starts slowing down, and eventually it gets to a point where it stops going up, and then it comes all the way back down. That whole time, it's just accelerating in the negative direction, which is what causes it to slow down as it's going up and speed up as it's coming down. And that's pretty much it for class today. Have a great day. I hope you guys are doing great. Bye.